Hello, good day, viewers. Let us go through these 50 questions of WAEC 2024 Mathematics Examination Objective Questions. And we have question number 1 here. We are asked to multiply 3.4 times 10 to the power of negative 5 by 7.1 times 10 to the power of 8. And we are asked to leave the answer in standard form. All right, let's get started. First of all, we can multiply these numbers together. Then we multiply this together because this is commutative, right? So I would like to arrange it as 3.4 multiplied by 7.1, then multiplied by 10 to the power of negative 5, multiplied by 10 to the power of 8. If you multiply these two together, you're going to get 24.14. And if you multiply this together according to one of the laws of indices, since they have common bases, you can take a base, which is 10, and you raise it to the power of the sum of their exponents, right? So negative 5 plus 8 will give us 3. So this is 3. But remember, they say we should leave our answer in standard form. So we have to shift this decimal point backward. So this becomes 2.414, then multiplied by 10 to the power of 4, because we have shifted the decimal point backward one time. So therefore, we have to increase this. And hence, this is the answer to the first question. Let us move on to question number 2. Given that P, which is a set of elements P, from 1 down to 20, excluding 1 and 20, for which this P is an integer, and we have another set R that contains elements R from 0 to 25 inclusive, for which R is a multiple of 4. We are asked to find P intersection R. So first of all, we need to list down the elements in P and R. So for P, since they are integers, P greater than 1, meaning we're going to start with 2, and P less than 20, we are going to stop at 19. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and finally we have 19. And R, which is a multiple of 4. What are the multiples of 4? We have 4 itself, plus 4 we have 8, plus 4 we have 12, we have 16, we have 20, we have 24. We keep on adding 4, but they set from 0 down to 25. Therefore, we have to stop here, because the moment you add 4 here, you have 28, which is greater than 25. So we want to find P intersection R. What does this mean? It means set of elements that they have in common. They have 4 in common, 8 in common, 12 in common, 16 in common. I think that's all. So we're going to list down 4, 8, 12, and 16. And hence, this is the solution to this problem. Moving to question number 3, which is under arithmetic progression. It reads, the first term of an arithmetic progression is 2, and the last term is 29. If the common difference is 3, how many terms are in the AP? So now let us write the data. We are given the first term, which is denoted by A as 2. Common difference D is equal to 3. Last term is given as 29, and we are looking for the number of terms. So which formula should we apply? Let's use general term Tn, which is equal to A plus n minus 1 times D. A is the first term, n is the number of terms, and D is the common difference. But remember, Tn represents every single term in a sequence. Therefore, we can substitute it with 29, because 29 is a term in the sequence, which is the last one. So we have 29 equal to A, which is 2, plus n, which is unknown, minus 1. D is given as 3. If you take this one backward, it becomes negative. We have 29 minus 2. This is equal to 3 times n will give us 3n, and 3 times negative 1 will give us negative 3. This will be 27, right? 27. You can directly take this one to the left. It becomes positive 3, and this remains 3n. This is 30 to the left, and this is equal to 3n. The moment you divide both sides by 3, you have 10 here, and this equals n. Therefore, n is equal to 10, which means that the number of times in this sequence are 10. This is question what? Number 3. Now let us move on to question number 4. Question number 4, we are asked to express log of x with the base of a plus log of y with the base of a equal to 3 in an index form. Remember one of the laws of logarithm, which stated that if you have addition between two logs of common bases, you can see the bases are the same. You can take a log with that base, log to base a, then you multiply the arguments, x times y, and this is equal to 3. But remember, we want to write it in an index form. So what is the relationship between logarithm and indices? If you have log of maybe a with the base of b, if this is equal to c, then the base b here to the power of c will give us a. This is the relationship between them, and hence we can say that a to the power of 3 is equal to xy, or you can say xy equal to a to the power of 3, all the same. And this is the solution to this problem. Let us move on to the last one for today. We have 2p minus q to the power of 2 minus p plus q to the power of 2, and we're asked to simplify. This is nothing but difference of two squares. If you have a squared minus b squared, this can be expressed as a plus b multiplied by a minus b, for which a here is 2p minus q and b is p plus q. So let's substitute. Therefore, 2p minus q whole squared, the minus p plus q whole squared. This can be written as 2p minus q, then plus the other bracket, which is p plus q, then multiplied by 2p minus q, then this time around minus, but as you subtract p plus q, the minus will affect the two terms, p and q. All of them will become minus, right? So 2p plus p will give us 3p. Then negative p and positive p will be 0. So we have only 3p from this bracket. Then from the other one, 2p minus p will be a single p. Then negative q is negative 2q. And hence, this is the simplified version of this. So subsequently, we are going to begin with question number 6 down to question number 10. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.